So, as you're spending some time this weekend, hopefully working on these gas laws, here's just a little gas law help for you as you're going through. And so, the biggest problem about gas laws is trying to figure out which formula to use. And so, here are a couple suggestions that I have for you. All right. So, if you are given two pressures, volumes, temperatures, or number of moles values, or one of something else, use the combined gas law. Of course, that combined gas law can also include Avogadro's law. If you're only given one pressure, temperature, or volume, and or mass of or number of moles, use the ideal gas law. If you're asked about partial or total pressure, use Dalton's law of partial pressures. And so take a look at these problems and you can feel free to work them. I do give the answers at the end. And if you have any questions, just let me know. So here's some examples of some potential problems. And so see if you can pick out which gas law to use. So take a moment, read this one. Hopefully you were thinking, oh, I've got to use Dalton's law of partial pressures there. Absolutely. And if you want to work this problem, I do have the answer at the end of the slideshow. How about this one? Okay, so as I'm looking, I'm noticing I've got a pressure here. So as I'm reading these, I actually write that. I see I've got a temperature, and then I've got another temperature. So I will call this one T2. So I've got one pressure and two temperatures. So hopefully you're thinking TP, that would be toilet paper, Gay-Lussac's law. Exactly. And like I said, I didn't work the problem out here, just reminded you of what the formula is to use. How about this one? So again, as I'm looking at this problem, I'm saying, okay, so I've got a volume right here. My pressure is right here. And I've got a temperature. And I'm being asked and that temperature is in Kelvin, so that makes it easy. And I'm being asked how many moles. So which formula would you use? Hopefully you're thinking the ideal gas law. And so R is always the same and it's given to you. If you want to take a look at if you want to work this problem and take a look at your answer again, it's at the end of the slideshow. All right, how about this one? So once again, I'm going to look at it. I can see that I've got a pressure right here. I've got a volume. Okay. I've got a temperature. Of course, I know that needs to be converted into kelvins. And I'm seeing I've got a second temperature. And I see that my pressure is going to stay the same. So that means I got two temperatures, a volume, and a pressure that's staying the same. So I'm going to, you could use the combined gas law and put that 1.05 pressure in, or you could use Charles's law where you're just putting in the volume and the temperature. All right. And again, if you want to if you want to work this problem and check your answer right at the end, how about this one? And so we've got to start with that balanced equation. And so for this one, you are going to, and so you're going to be using that 22.4 and that balanced equation. And let me double check to make sure I did work this one all the way through. If you have any questions about it, just let me know. Here's another one. So that's going to be, again, our stoichiometry and gases. How about this one? So I can see that I've obviously got a chemical equation going on again. So I'm going to try to write that balanced equation. And then I'm going to start, as always, with this right here. I'm going to start with the given. I'm going to convert those grams to moles, then use my equation to look for moles to moles, and keep on going like that. All right. And so, like I said, you may want to work those problems and check your answers. Now, on your ideal gas law lab, that is going to be due on Sunday, the only lab that you have due this week. Several people have asked me different questions. There are some pre-lab questions for you to work. Here is, I believe, number 5 from the pre-lab questions. And so again, taking a look at this the same way, I can see that I've got a mass here. So I know from mass, I can get my number of moles. I see I've got a pressure. Millimeters of mercury is going to be a pressure, and I've got a temperature. So what formula am I going to want to use here? Hopefully you're thinking, oh, you're going to want to use the ideal gas law. And I am, but there's some problems here. I'm going to use that ideal gas law, but I can see that I don't have moles, and my temperatures in Celsius and my pressure is in millimeters. So I'm going to have to do some conversions before I get started. So first, I would convert those grams of chlorine to moles of chlorine using my molar mass. And here you can see that my grams of chlorine are going to cancel right out. So I'm going to get moles of chlorine. I'm also going to have to convert my pressure to atmospheres, because anytime I'm dealing with the ideal gas law, because of R, my pressures are going to have to be in atmospheres. So I took a look at my reference sheet. I could see that 1 atmosphere of pressure is 760 millimeters. And so I converted that. Then, of course, I converted my temperatures to kelvins. And then, of course, I'm going to put all of that into the formula and attempt to solve for V. Now, I can do it like this and try to get V by itself. In order to get V by itself, I'm going to do the opposite of what's going on between 0.596 and V. And that 0.596 and V are being multiplied. So the opposite is going to be division. So I'm going to divide both sides by 0.596 atmospheres. And because they're equal, whatever I do to one side, I do need to do to the other side. So again, I'm going to divide by 0.596 atmospheres. Oh dear. Oh, let me exit that drawing, hopefully. Okay. And so as I'm doing that, that's going to cancel out my atmospheres, and my 0.596 is going to cancel on the left side of this equation. Or I can rearrange the equation in terms of V. So I can say V equals all of that divided by 0.596. And I'm sorry, there should have been a line right here. I don't know what happened to my line. All right, and so as I was saying, there should be a line right here. And so then you can solve for V. Now, I didn't do that for you. Notice that atmospheres are going to cancel, kelvins are going to cancel, and moles are going to cancel. And if you wanted to go ahead and work those other problems, here are the answers there were 6 problems right there. And so here are the answers for those 6. If you have any questions, need any help, please reach out so that I can help you.